So I'd like to talk to you a little bit about this, the role smallholder farmers in developing countries can play in, and some people call it a new green revolution, or an evergreen revolution, or some people call it sustainable intensification. And the basic idea is that I think there is a wide recognition of the fact that agriculture is going to have to change as environmental pressures grow, resources become more scarce, but food production has to increase. And as part of that, that means that the amount of food we produce per unit of environmental inputs, whether it's water, energy, nitrogen, chemical fertilizers, or pesticides, has to increase dramatically. And some people call it sustainable intensification, another green revolution, evergreen revolution, and so forth. And smallholder farmers in developing countries really have to be part of this new revolution, partly because they produce a lot of the global food production, and partly because they are especially, they live in areas and they work and cultivate in places that are going to be very, where these pressures are going to be especially strong. And finally, from an economic social point of view, these are the people who are most susceptible socially to the possible loss of income that's going to be associated with that. So for all those reasons, smallholder farmers need to be a part of this. And just to give you a few examples of that, if you look at like where there's pressure on groundwater, where groundwater is being depleted, so you can see, I don't have a pointer, right?
Do you have a pointer? Oh.
It's okay, it's not essential.
Sorry.
It's okay, it's not essential. You can see that a lot of the areas where there is strong groundwater stress, where groundwater resources are being depleted, actually is in northwestern India and in North China, and some also in the Middle East. So many of those places are where farmers are smallholder, and these countries are still developing countries. Okay, so that means the environmental pressure from the water side is especially strong for these farmers. And the same thing is if you think about overuse of nitrogen fertilizer, which is actually common around the world, but you see the green colors indicate overuse of nitrogen fertilizers. That's especially strong in India and China, where hundreds of millions of smallholder farmers are cultivating, right? So the need to manage with less of these resources is very pertinent for smallholder farmers in developing countries. And the question is, what will it take to help shift these kind of farmers to a more sustainable mode of production? And specifically, the technologies that enable farmers to do that exist. It's not science fiction, right? It's possible to manage with less water. It's possible to manage with less fertilizers with the appropriate kind of technologies and practices. But the rates of adoption of these technologies and practices is quite low, especially in developing countries. And so the question is, what will it take to achieve that kind of transition? And I think there are two kinds of broad opinions or points of view of what will enable that to happen. One is the idea that it's going to be scarcity. As scarcity increases, the incentives will grow to transition to this more efficient use, to adopt these technologies. So that will just take care of itself. And that can mean either that like water can become more scarce, so by itself farmers will start to use water more efficiently, or let's say that the pressure can come from regulation. Governments are going to start getting very nervous about this, and therefore they are going to start regulating farmers more. So that pressure or that incentive, those incentives are going to increase to lead farmers to adapt. So in other words, nothing is really needed. The scarcity, growing scarcity by itself will create that kind of feedback that will move farmers to this new mode of cultivation. And an alternative approach is, no, we can't just wait. It's not just going to happen by itself. We need the public, the government's public sector has to be more proactive about pushing those technologies, extending those technologies to farmers now, earlier, not just to wait till scarcity may do it on its own. So I think that debate between those two points of view is really at the heart of what a lot of the discussion of sustainability is about. And what I'm going to try and do is I'm going to try to actually look at these questions like it's at limited dimension of this question empirically. So I'm actually going to use empirical methods to actually look at farmers that are exposed to these kind of patients and see what they do. Okay, so it's all field research, empirical research, trying to get some insights into that question. You know, I'm just starting to learn from some of my friends here about how to think about socio-ecological systems, and I think that may be an example of like one possible feedback, like as environmental scarcity increases, does it create a feedback that moves production to a more sustainable track or not necessarily? So I'm going to just try to get some empirical evidence of that. And the first and main example in which I want to talk about this is the story of water in India. There's a big water crisis in India. Most of it is just coming because of water use in agriculture. All of those red parts of India are parts where aquifers are being depleted because farmers who heavily rely on groundwater for irrigation are pumping more than the natural recharge rate is. So as a result of that, water tables are falling all over India. There's a great deal of concern around that. But very little understanding of what actually the eventual impacts are going to be. And you know, one of the amazing, almost a paradox is the contrast between the fact that water is becoming more and more and more scarce. And you know, I travel around a lot in India, and everywhere you go, the one thing farmers want to talk about in very different parts of India is always about water scarcity. So there's a real contrast between the fact that water is so scarce and the fact that almost all farmers in India are still using water in a very inefficient way. They're just flooding their field, which is, from a technical point of view, that's very wasteful of water. So how come, what is the root of this, contrast between the scarcity and how water is used? A lot of people think that that's because water is not priced or regulated. And even the electricity, the energy that farmers use to pump water, even that is not priced. It's just given for free by most of the state governments of India. So one of the main theories of what is the root cause of this water crisis is the fact that there is no incentive, no regulation. So the question is, again, given all these scarcity, why are Indian farmers not trying to adapt more water-efficient cultivation technologies? And so again, some people think it's because they don't feel the scarcity yet. It's true water tables are falling, but once they actually right now they are just deepening their wells to use more water, so they are somehow managing with that. And maybe once they don't have enough water to cultivate their fields, maybe then they'll start using it more efficiently. Another theory is there's pricing, that there is no pricing of either the water or the energy. And then the other point of view is that technologies are too expensive, unfamiliar for farmers and so on, and really governments should do something to help farmers adapt these technologies. So I'm going to present you a short series of studies, field studies, that try to actually gain empirical evidence on which of these is like the main constraint on farmers. So the first one is really trying to understand empirically, is it really true that once scarcity becomes worse and farmers really feel the pain of water shortage, is that by itself going to lead them to start using water more efficiently and adapt all these water-saving technologies? And to do this, we are making use of kind of a natural experiment in a part of northern Gujarat. It's a very dry area. It's that square over there, where there's very little rain, but agriculture has boomed for the last 2-3 decades because of using groundwater for irrigation. But the water table has really been falling very rapidly at the rate of 3 meters per year, and right now farmers are pumping water from 300 meters often. So think about the fact that they are pumping water from 300 meters, using a lot of energy that is provided by the government at basically zero cost, and then they are just flooding the field in a very inefficient way. But here we have a natural experiment because there's a lot of geological variation in the characteristics of the soils and the aquifers themselves. And one very interesting thing is that there's a particular variation there, that there is a feature called a dark clay layer, which is a very old form of clay that exists under some villages but not under other villages. And those villages that sit on top of that clay, dark clay, they are experiencing more severe water scarcity, because once you go through that clay, as you try to chase the water table, you're encountering an aquifer that doesn't get replenished. It's pretty fossil, so the water table starts to fall much faster, and that water also tends to be saline. It's very old water. So those villages that are marked by black dots are the villages in this area that have this dark clay, and therefore the water situation in those villages is worse than other villages, the ones in green, that do not have that bad geology. So that creates kind of a natural experiment where some villages are more scarce in water than others. And that gives us an opportunity to compare what farmers are doing in these two different types of villages and to learn about what scarcity actually does to farmers. So in a nutshell, I'm not going to go into all the details. In a nutshell, what we find is that what farmers are trying to do in their more water scarce areas, they are trying to drill deeper tubules to start to somehow keep up and get more water, but it's not really working because it's not just a matter of the water depth. These aquifers are actually really getting empty. So there's really no water left in them. So that is not really working, and the indication of that is that if you look at how much land is actually cultivated, and we use it as a measure, the measure we use is called irrigation or cropping intensity, which is how many crops are being grown in a given year outside of the rainy season. So the maximum you can have is two more crops, two more croppings in the same unit of area. And when we look at the villages that only have moderate scarcity, they don't have that dark clay layer, it's 1.25. If you look at the villages that do have the dark clay and have more scarcity, there it's much lower, okay? So it's 0.9. So you really see, and if you look at actually at Google Map images of the area, those villages with dark clay actually have more brown around them, okay? So that means agriculture is actually shrinking. The farmers are not able to maintain the extent of cultivation when they are facing more scarcity. And again, remember, that's not obvious because there are technologies that could help them manage with less water. But we don't see them do it. Agriculture is really shrinking as a result of greater scarcity. What we do see happening instead is an abandonment of agriculture. So from those villages that are more scarce in water, there's more exit from agriculture and migration, leaving the village by young men especially, and going to cities. But that's only happening for the higher castes, those who are connected and have the social networks. They're leaving those villages, and the lower caste have to stay in the village, and a lot of them shift to rain-fed farming. They're basically not managing with less water. So the bottom line from this study is it seems that as a response to scarcity, we don't see that optimistic projection that somehow farmers are adjusting. We don't see that there is sufficient adoption of water-saving technologies. Instead, we're seeing basically abandoning agriculture. And if the same thing happens on a large scale when water in the rest of India starts to become that depleted, then that will be bad news for food production, for food prices internationally, and so forth. So that's one study. The other one is we try to see, what about pricing? Maybe it's a story of prices. So maybe if you actually introduce pricing to Indian farmers, where that will create the incentives to use water more efficiently, right? So that's another kind of a pressure or incentive. And it's difficult politically to price water in India. It's a very difficult political problem. Every politician that tried to introduce pricing, not of water, but of the energy that is used for pumping, has been basically kicked out of office. And so we worked with the government of Gujarat to try and introduce an alternative way in which you're not going to charge farmers for the water, but you're going to compensate them for any voluntary reduction in the amount of water that they use. So that should be creating a similar incentive for efficiency. So a lot of people thought this is not going to work, but in fact it worked very well in the sense that the utility company implemented it, farmers did not cheat, there was no tampering with meters. All of the bad things people expected to happen did not happen. This was the first time in decades that in India a public utility actually measured the usage of farmers, how much energy they're using to pump water, and charged them based on that. But the other surprising news and the more negative news is that it did not lead to any difference in water use. So if we compare the farmers who received the incentive to a control group of farmers who did not receive the incentive, there was no difference in how much water or energy they have used after the incentive was introduced. So it doesn't seem that it really led farmers to change their behavior, and some farmers actually came to our field office and said, we really want to save, we want to get this benefit, we want to get the incentive, but we don't know how to save water. So we need help, we need extension, in other words, We need to find out, give us technologies, give us ways to save water, and then we'll be happy to respond to the incentives. So that maybe, for me, that was a turning point that suggests that maybe it is really important to like push these water-saving technologies and extend them to farmers and not just rely on prices, on scarcity to do the job by itself. You know, but when we talk about adoption of technologies by, in general, in developing countries, this is a difficult issue for many reasons. And I think it's especially puzzling when we talk about technologies that are not only green, but there are many technologies that should help farmers increase their yields and simultaneously also reduce the amounts of inputs they need. So for example, drip irrigation or sprinkler irrigation enables you to get more yields with less water. Or there are ways to use less fertilizer and increase the yield also. So from an income point of view, those are technologies that should, on paper at least, really improve farmers' incomes, and yet we don't see them really being adopted. So we try to ask why. Why are farmers not adopting these technologies? And you know, in general, in development economics, there's a large literature trying to understand these questions, not just for green technologies, but for many other types of technologies. Why are farmers not adopting technologies that look profitable, at least in theory? And there's a number of hypotheses about what is the main constraint. Some people feel that it's just that farmers are not familiar with these technologies. So from their point of view, there is a huge risk associated with adopting unfamiliar technologies, and maybe providing them some kind of better information, better extension, better confidence can make them adopt these technologies. Otherwise, another hypothesized issue is that these technologies are often expensive, and even if they pay for themselves in the long run, the initial payment is too high for farmers to bear, especially if they don't have access to credit and so forth. And that suggests that maybe subsidies could help, maybe credit could help, maybe getting farmers to work in groups in order to achieve economies of scale can help because that reduces the cost per farmer and so forth. And then there's another question, I think, which is, you know, often we think these technologies are really attractive, but we don't sufficiently understand the reality of these farmers, and we don't appreciate that sometimes they're not exactly what farmers really need. And I don't have time to give you examples of that right now, but we see them a lot, these kind of examples. But I want to show you something more optimistic. It shouldn't be all like, you know, doom and gloom. So I want to tell you about drip irrigation, which is, again, one of these technologies that's supposed to save water and increase yields. And the Indian government actually is very excited about drip irrigation. So India's government, central government, actually is willing to pay half of the cost of any drip irrigation systems that a farmer anywhere in India will adapt. So that's a substantial financial commitment. And despite that attempt to help farmers, you don't see that there is a great deal of adoption of these technologies. So the question is, why is subsidy not working? Maybe subsidies are just irrelevant. Maybe they're no good, they don't work. Maybe those farmers who would adopt without the subsidies, and those who do not want to adapt, the subsidy may not help them. That's one possible explanation. Maybe they're not administered in a proper way. But in a particular state in India, actually, we actually see a great deal of adoption of drip irrigation in the last 10 years. So in this state of Gujarat, is the same state that I just told you about. There are about 500,000 farmers who have purchased drip irrigation or sprinkler irrigation in the last 10 years. And we are trying to understand really what's driving that. And as part of that, we actually collected data on every one of these 500,000 adoptions of drip irrigation. And we managed to find out which village that farmer was in and map it and find the coordinates and put it on the map, so we can see the dynamics of how this technology spreads over time as the months change from month to month. You see that every green dot you see, every big green dot, is one particular farmer adapting drip irrigation somewhere in Gujarat. And then the small green dots are villages that have already at least one drip irrigation by that time. So you see how gradually this really spreads and starts to cover very large areas of the state. But looking at all this data can help us really answer empirically with data some of these questions about what is driving farmers to adapt or not to adopt these technologies. For example, we can ask the question about, are subsidies really helping farmers adapt these technologies? And to do that, we use the fact that the level of subsidy actually is not always constant. Sometimes it's not just 50%. There are certain locations and times in which governments actually, some NGOs or some of the drip companies themselves actually increase the subsidy by 10, 15, or 20% for a limited amount of time. And then if we look at those places and times and to see whether there is an increase in adoption of drip, we do see a very large increase. So the number of purchases actually goes up by 30% during the times and in the places where the subsidy levels are higher. And that's a very large increase. It suggests that subsidies are actually an important factor in the decision of farmers to adapt drip. So probably subsidies are important, but they have to be administered well and delivered well as they are being delivered in this particular state of India. We also see that, for example, farmers' decisions to adapt drip is very much influenced by the decisions of farmers in their area. So it seems like farmers are really learning from one another about the benefits of this really unfamiliar technology. We also are looking at whether drip is actually saving water, because that's an important issue. There's an example of, somebody gave me this example today about sometimes when you install, there's efficient water-saving shower heads, people tend to take longer showers, and that can potentially offset the impact of the technology. So somewhat similarly, if you give people a technology that requires less water, it's not actually clear that they will use it properly and save water. Maybe they'll use the same amount of water and actually just expand the amount of area they cultivate. Maybe they'll sell the excess water to their neighbors. So it's not actually clear that the government's goal of reducing water use is actually benefiting from pushing these technologies. So what we did, we took a lot of these farmers that are adopting drip and we kind of managed to get their electricity bills from the local utility, and then we can see whether the amount of electricity they use for pumping changes after the time that they adopted drip irrigation. And this is very preliminary, so we're still collecting data on this, but we're starting to get results that look like this, that 0 is the time in which they adapt their drip irrigation. So you see, before 0, we don't really see too much going on. And after they adapt drip irrigation, initially their usage actually goes up, but in the long run, it may actually be going down substantially after 3, 4, 5 years. And talking to, this is very much still in progress, but talking to like people from the irrigation companies who sell these products, they said that this is exactly what they expect, because from their experience, farmers are not using the drip properly in the upon adoption. They don't believe, they need to see water like wetting the ground. They're used to seeing that, and unless they see, they don't believe that the crop can grow. So it takes them a long time to develop confidence in the concept that you can just, those few drops going into the root zone can actually make crops grow. But eventually it may be happening. We can also see, and I think another important lesson is that the idea is about trying to help the poorest farmers, right? The really smallholder farmers. So if we develop the farmers into 5 classes, marginal, small, semi-medium, medium, and large, where marginal is basically like about an acre, so very, very small, the poorest farmers, most farmers, the blue bar is showing you, most farmers belong to that category. But the drip adopters are much more likely to be the larger land holdings, like this medium, semi-medium, or small. The marginal farmers, who are the smallest and poorest, and the majority of actual farmers, are not the ones who are really taking part in this revolution. So that's as far as the example of water is concerned. Just really quickly, another example is the story of fertilizer, nitrogen. So if you remember, there's basically, in India especially, farmers tend to overuse nitrogen more than the crops actually require, and that's been shown to have implications for water quality and even for infant mortality. So how can we get farmers to actually use less fertilizers, which they actually have to pay for, and without harming their yields? The potential is definitely there, but how do you get farmers to do that? And again, one of the theories is that there is a substantial subsidy on nitrogen fertilizers. It actually costs the Indian government 1% of their GDP to subsidize those fertilizers, and maybe that's why farmers are overusing fertilizers. But the alternative point of view is farmers just don't know that they can use less, and if you could actually provide them that information in a way that they will be confident about, that may actually help them to shift their cultivation to be less consumptive of nitrogen. So these, and the Indian government, instead of trying to remove the subsidy, it's just like in the case of water, instead is trying to basically subsidize and support farmers in reducing their fertilizers. There's a particular example that the new Indian Prime Minister is very excited about. It's called soil health cards. And the idea is to send agricultural university students to basically every farmer in India, take a sample of their soils, take it to a lab, test it, and return and give the farmer a card which explains the structure of their soils, in like what, if they're deficient in any one of these elements, and then give them specific recommendations based on their soil composition about how much fertilizers they need. So it's a great idea, it seems, and it's huge amounts of money are being spent on this initiative, but we don't really know whether it's actually helping farmers, it's affecting farmers' decisions. You know, if you had a chance to interact with Indian farmers, you know, it's not that easy to convince them to really shift their cultivation patterns, and it's not clear just giving them a piece of paper with like lab results and recommendation by itself is really going to shift their way they cultivate. So we decided to actually test it. So this is the Prime Minister of India announcing one of these grant schemes, and we're trying to test it. So in the state of Bihar, we actually are doing a random experiment where we selected randomly 500 farmers and did exactly what the government is doing and planning to do, which is just to take their soils, test them, and give them their results. And while I don't have results because we're collecting inline data right now, from visiting the field, you know, it's pretty clear that most farmers were not exactly like ecstatic about this information and are not going to dare to change their cultivation just based on that. And, you know, I don't blame them. I don't think I would really probably shift because, you know, I think the risk to a farmer, the perceived risk of saving some money on fertilizer and then maybe suffering substantial yield losses is not trivial. So we're trying to think about what can we add in addition to just the information to maybe help farmers actually change their usage. Similar with pesticide, you know, we are working in the southern part of India. This, again, it seems farmers are really using a lot of pesticides, often because they don't know what they need. So when they see a pest, they just basically, their main source of advice is the input dealer in the local pesticide shop, who often also maybe don't know too much. And it's not based on the identification of the particular pest. And they buy a lot of bottles of pesticide and just dump it in the field. You'll go to farmers there and they'll show you all the empty bottles they keep. They don't even know what they're applying. They're not protecting themselves. And there's a lot of people think that this use of pesticide is a really serious public health problem in India. So we're trying to see if maybe just giving numbers like a phone line where they can use or maybe send pictures from their mobile phones of pests can help them figure out what they actually need to apply and maybe reduce pesticide use. And, you know, to end, I want to like throw out there like a provocative little thought that is, in the realm of cotton, there are a lot of initiatives now to reduce the amount of pesticide used in cotton and water and pesticides. And there is one initiative called the Better Cotton Initiative, which is an initiative that's more based on like, and it's run by a group of industries, including IKEA, by the way, who really want to source better cotton, produce more sustainably from smallholder farmers. So they go to farmers and they explain to them, they sit with them and they explain to them that slowly that they can use more like biological pests and less fertilizers and all this. And, you know, it seems to have some success. I was in the field talking to farmers. They report actually having reduced some of their fertilizers and pesticide use, but, you know, it's an enormous effort. It's not clear how well it's working in scale. And then compare this better cotton to the BT cotton, which is obviously a genetically modified strain of cotton, which supposedly requires much less pesticide. So I don't know if it's really actually leads farmers to use less pesticides, but in terms of diffusion, BT cotton is something that has diffused all over India very rapidly. And I think we may have mixed feelings about these kind of technologies, but I wonder if, and this is something that we need to understand better, but I wonder if maybe technologies that are easy to adapt, because and diffuse fast, mainly because they increase yields and also have the side benefit of enabling reduction in pesticide use, maybe, and I'm just raising the question, I'm not saying that, but I think we should really try to understand of between the two approaches, which one is a more feasible way to make agriculture more sustainable. You know, even drip irrigation, farmers are not adopting drip irrigation because they want to save water. They're adapting it because they want to make more money. And but it could be that there is a beneficial result of that is lower use of water. So I think just to throw out some ideas out there about how to think about what's the best ways of achieving these goals, and that's basically it. I'll end there.